The default assumption for most people in the West is that the brain generates consciousness. So something brainy, neurological happens, neurons are firing, and then consciousness pops out like steam from a kettle. Now, you think this is not just wrong, you think it's confused. Before we get technical, what's the short version of what you think's actually happening?
What actually is happening here is a physical process and not only a computational process. Because of relativity, that from the outside we can measure neural patterns, and from the inside we measure a new physical entity, which we call consciousness. So this is like a one line, of the theory.
Okay, explain how most people, most of your colleagues who aren't educated in these matters, think of consciousness.
I guess, so if we take people from the street and ask them, what do you think about consciousness? Most of the people, including me when I was a child, would think that consciousness is separate than matter. It's something different, very dualistic way of thinking. I guess maybe because of the influence of religion, we tend to think of a soul or something like that, right? But then we saw that actually there is not only great correlation between consciousness and the brain, but also causation. If we stimulus an area in the vision cortex, for example, we can create a conscious experience of seeing, even though there's nothing there, just because of the electricity of the stimulus that we gave. And in a different area, if we will stimulate, the person will say that they feel, for example, humor, or that there is something that is funny all of a sudden, right? So we have this causality between the activity of the brain and consciousness. So you would think that consciousness is just something that emerges from our brain. And if we know enough neuroscience and we understand enough the computations of the brain, then we will explain the emergence of consciousness. But it's not the case. I mean, in philosophy, for millennia and in recent years, from let's say the 70s, we know that there is a very hard problem here. There is a mystery, a big mystery about consciousness. I think that most of scientists and neuroscientists don't appreciate enough this hard problem. But it's there. There is a really big mystery here. We cannot just say that, consciousness is computations of the brain.
Look, for those who are just tuning in, we'll go over your relativistic theory of consciousness, which has over 100,000 downloads, by the way.
True.
And it will be explained extremely simply to the audience with intuitive analogies. I'll even explain your own theory back to you to ensure that I understand it, and then I'll tell you what troubles me about it.
Sure. Excellent.
Anyhow, you said something super interesting, if I heard you correctly. It's that it's not just a computational process, it's a physical process. So many viewers of this channel may have heard of the Church-Turing thesis. Maybe they've even heard of the physical Church-Turing thesis. Are you not accepting the physical Church-Turing thesis? Do you think there's more to physical processes, to physics, than what's computational?
So I think that there are two questions, separate questions here. One is about the computations, and the Church-Turing hypothesis is about the ability that if something can be computed, then we can build a computer, or like a Turing machine that will compute it. With that, it's I have no problem, let's say. But it doesn't mean that our brain only create computations. I mean, of course, our brain create lots of computations. This is what a cognitive system does. It gets information from the outside world, manipulate it with computations, and create representations, and in the end of the day creates outputs. What I'm trying to say that it's not enough in order to create consciousness. Now we'll see, soon we'll see why. I mean, the problem here is the proper name for this problem is the explanatory gap.
Mm-hmm.
Now, because of the explanatory gap, it's not enough just to speak about computations. Now, so what do I mean by that? The explanatory gap is because, let's say that you are feeling happiness right now, because talking with me, it's such an amazing event.
Right.
You see, I know everything. Now, now let's say that I can check your brain, and I will find the neural pattern of your happiness. But I will not know that this neural pattern is all about your happiness. I need to ask you, what do you feel right now? What do you experience? And then you will tell me, oh, I feel happiness, which is already a bit weird.
Yes.
That it's not public. I don't know what you feel. I don't know what you experience. I need to ask you in the end of the day. But then it's not enough, because we think that the brain creates our conscious mind. So I would expect to find in your brain all the process of creating your experiences, like creating your happiness, for example. Or you know what? Let's take even a simpler example. Let's say that you see now my glass here, and you have experience of this glass, right? And I will check your neural patterns until I will find a representation of this glass. But this representation is not the actual experience that you have of the glass.
Mm-hmm.
Because this representation is a state in our brain, right? So when we look at the brain, we try to understand how it works, and we can check like the space of all states that the brain can create, our neural network. It's a vast neural network, so it's a vast state space. And then one of those states will be the state that represents the experience of this class. Now, when you experience it, you experience, something that has a bit of a blue color and some kind of a height, and it's a 3D shape, right? But then when I check on this state of this representation in your brain, I will see something completely different, because this state space is composed of the variables of how your brain works. For example, maybe it will be, one of those variables will be the voltage of the membrane of your neurons, or maybe another variable will be which chemicals are being released right now over there. So we have lots of physical processes, and all of them together create this state that represent the glass. But in the end of the day, what you experience is something completely different. It's something with colors, with height, 3D shape. So where is it in the brain? How can the brain create it, right? We assume that the brain needs to create all those properties that you actually see, that you actually experience. But then the representation that I see in your brain has a completely different kind of properties. So where in the brain, we can see the creation of the actual experience, of the actual glass? And the answer is that nowhere in the brain, because the brain can do one thing. It can create neural patterns. and it can create more and more neural patterns, more and more complex emergence of a complex neural patterns, but it always stays with neural patterns. So how can those neural patterns be translated into the actual experience of a glass?
Okay.
This is, in a nutshell, the hard problem and, the explanatory gap. There is a gap here between the first person point of view, the experience of a glass, and the third person point of view when I look at your brain and see only neural representations. And it's not clear how can there be even a reduction between, the experience of the glass to the actual patterns in the brain, right? So that's why we cannot say, it's not enough to say that, the brain just make computations, because all those computations, this is exactly what what I described before with this state of, of neural patterns. And it's not enough in order to explain how the conscious experience is being created, right? And that's why it hints that we need more than just computations in order to understand this, mystery of consciousness.
Let me see if I got this correct. In a third-person scientific point of view, there's something of a neural state. Let's call this P for your brain. And then there's something that some P's, so some neural states correspond to, or they seem to produce, like a Q. Let's call that the first-person qualia, or the first-person phenomenal consciousness. So if P then Q. But if P then Q doesn't seem to follow from logical necessity. It just seems to be something extra added on. And the question is, well, where does this if P then Q come from? And are Q and P of a completely different nature? Are they twins of the same coin? Some eliminativists will just say that Q is equal to P. Some illusionists will say that Q should be replaced with Q star, some diminutive version of Q, that in fact there is no qualia. That's a Daniel Dennett type phrase. So there are various responses. And then a Bernardo Kastrup may say something like, well, the P comes from the Q.
Right.
So one way of looking at the explanatory gap, at least for me, is to think in terms of this conditional if P then Q, and then what's the relationship between P and Q and the truth value of this and where it comes from. Tell me if I'm wrong.
No, you're right. It's a good way to present the explanatory gap and the hard problem. I think that it's not enough. If someone is here for the first time and hear, this hard problem for the first time, I think it's not enough in order to understand why there is a problem here. I think it's the deeper layer is to understand that we cannot identify between the neural patterns and the computations with the experience just because they are very different from each other. They have even opposite properties. For example, again, your neural patterns are public. If I really want, I can, open your brain and see your neural patterns. But your experience is not public. So we have here a property that is actually opposite between the two. So there cannot be identity because of that, right? If there is an identity, then everything should be the same. But it's not the same. Actually, we have property that is the opposite between neural patterns and computations and your conscious experience. So they cannot be identical. They cannot be the same. And then also it becomes much harder to explain how those experiences can come about from, neural patterns. How can you do this reduction if they have such different properties, even, opposite properties? I think this is the essential part here. You know what? I have another example for that. People sometimes ask me, isn't it a bit like a computer? Like the brain is, like in the computer, we have zeros and ones. We have the machine language. And this is if we take the brain as a computer, we have the machine language of the brain, all those neural patterns.
Mm-hmm.
But then, in the end, you can see on the screen of the computer some images. This should be consciousness. This should be our conscious experience. What is the problem with that? The answer is that with our brain, we cannot find the screen, the screen of the computer in this analogy. We only have more and more machine language, more and more neural patterns, and somehow, miraculously, from those neural patterns, boom, you have the screen. But where is it? If we think that that with science we need to explain everything, right? With physical mechanisms. So what is the physical mechanism that takes us from those the language of the brain to the actual screen where we can see the experiences? And there is none. The brain only have those neural patterns, So this is the hard problem in other words. At least how I see it,
Okay, now what is your response to the hard problem? What is Nir Lahav, physicist Nir Lahav, what is your theory of consciousness?
Okay.
And why is it called a relativistic theory of consciousness?
But before that, we didn't speak about what is consciousness to begin with, because for many people it can be something different. So just let me say very briefly that consciousness, there is a canonical way of thinking about consciousness from Thomas Nagel in the 70s, that consciousness is if the creature has something that is like to be the creature, then this creature has consciousness. So, for example, when we awake, or when we are dreaming even, we have something that is like, again, you have something that is like to see this glass. You can, for you, it's like, no, it's round shaped and so on, right? But then when we in deep sleep or under anesthesia, we have nothing that is like. It's all black, right? Nobody is home. And that's why you don't have consciousness then, right? So this is what we try to understand, this something that is likeness. This, right? And the problem is that we cannot find how we can do a reduction from this property that we have something that is like to experience ourselves and the outside world. How could we do reduction from it to brain patterns? Okay? So just to be clear for what we are talking about here.
Sure. When I'm deep in research, reading papers on, say, the philosophy of mind or quantum gravity, it may seem sterile, but I still don't want my ISP logging every single page that I visit. ExpressVPN prevents exactly that. Your internet service provider, your ISP, can see, they can log, and they can, in the US, legally sell a record of everything you do online. ExpressVPN encrypts all your traffic and reroutes it through secure servers so your browsing history stays entirely yours. I travel for interviews and conferences constantly, and connecting to hotel airport Wi-Fi without protection is something I'd often kick myself for afterward. ExpressVPN's encryption makes those public networks safe. It can be used to totally unlock geo-restricted lectures and content by changing online location to any of 105 countries. There's no compromise on speed either. It's consistently among the fastest VPNs out there. The fragility of hunting for workarounds just vanishes. Find out how you can get up to 4 extra months by clicking the link in the description box below, expressvpn.com/theoriesoferythingyt. That's expressvpn.com/theoriesoferythingyt. Now, one of the reasons why I used to ask for people's definitions of consciousness, and then I stopped, one, because many people had different definitions, and another was because I kept hearing what it's like, and that never satisfied me, because people would propose it as a definition as if it's not circular. So if I said, what is consciousness? And then you said it's experiential. You experience something. Then I could just say that's a synonym of consciousness and it's circular. But then someone says, well, what is consciousness? It's what it's like. And then I say, well, what the heck do you mean by what it's like? And you couch yourself in to some experiential element anyhow. So you're just 2 nodes deep of a circularity rather than 1 node deep, which isn't much of an improvement on circularity. What do you make of that?
So I think that it does capture something important about consciousness. At least it capture what it's not, because it capture the fact that when we in deep sleep with no dreams, for example, we have nothing that is like, it's only black. It's, even to say black, of course, it's not, it's just a metaphor, right? We are just not there. And all of a sudden, when we wake up, boom, everything comes back. So I think that this definition, to have something that is like, at least capture that, this difference. But of course, it's not ideal, but it gives us something to work with, a starting point. Because without that, as you said, different people can define consciousness vastly different, and then we will speak about different stuff, and we cannot make any progress. So we need to start somewhere, right? Even if it's not a very good definition. And in physics, by the way, we don't really use lots of definitions. We use much more the relations, like equation. If you can think about an equation, it's more about the relations between different properties, like F equal ma, so you have those properties of force, matter, acceleration, and what are the relations between them? No one asks exactly, okay, but what is the definition of a mass? It's actually not that simple. What is the definition of energy? Right? Because you can say, yeah, we know that mass is an energy, E equal mc square. Einstein showed us that mass is just a form of energy. But then, okay, so what is energy? Oh, okay, this is a weirder question, right? It's not exactly clear what energy is. So again, definitions are not that important. It's just a good starting point. So we will be on the same page here. Okay. So, and that's why for me it's good enough.
I actually have a video about how global energy in general relativity isn't a well-defined concept. That is something that the audience can click on if they like. I'll put a link on screen. Anyhow, it seems like most of the groundwork has been laid. So let's get to your theory. And it's going to be developed slowly over the next 2 hours. What is relativistic consciousness? So if you're listening and you're not getting it, just keep listening, because I want to make sure all the conceptual scaffolding is there. I imagine that'll take a couple hours. So now let's get to your theory.
Okay, so because it seems like neuroscience cannot really solve this explanatory gap. It always stuck in the third person point of view, right? So we need something completely different. Now, to be fair, it seems like physics also will not do the trick here, because physics also tells us about relations from the third person point of view. But the thing with physics is that it's very unintuitive, and it has lots of explanatory power, which is very intuitive. For me, let's say, it's a bit like, there is this Plato cave analogy. For Plato, more than 2,000 years ago, and he said, maybe all of us are in this cave. We cannot see what is out there, what is the real reality. We see only those shadows in the cave, and we think this is it, but it's an illusion, right? We need to go out of the cave to understand what is going on there. Now, if Plato is right, and we do live in this sort of illusion, right? See only shadows of the real thing, then it means that when we will walk out the cave, slowly but surely, we will see surprises. We will see things that we are not used to, right? Because we are stuck in the cave. Our common sense is developed for the cave. So when we go out of the cave, our common sense will fail us, and everything will be weirder and weirder and more abstract. Interestingly, this is exactly the situation with physics. We try to understand what reality, we try to understand the theory of everything. And then we found ourselves understand how reality is much weirder than we thought, and very not intuitive, and our common sense breaks over and over again. Even think about Newtonian mechanics. Over there, already it was weird for people that actually we are moving, although we cannot feel it on Earth. And later on, Einstein, with special relativity, is like time is fourth dimension. Past and future coexist. Wow, it's crazy. And then general relativity. The Big Bang. We started from there, and like space-time actually created in the Big Bang. So many weird things. And then, of course, quantum mechanics. Don't let me start with quantum mechanics, right? Like superpositions and everything, right? So it's become weirder and weirder. And because of that, we can hope that maybe there is a trick here, or something that we can use in order to explain also consciousness. Because physics, it's much more than just to speak about matter. What is matter? Now, according to our most advanced theory, if we think about matter as mass of particles, this is not something that is the elements of the universe. The elements are fields which possess properties like energy, like momentum, and then those fields can rotate and create, like something that looks like particles for us, right? So when we think about the brain and we think about materialism and reduction, it's it's too simplistic. We know that nature is much more beautiful and deep and weird than that, right? So then I asked myself, what can we use from physics, maybe in order to understand consciousness? And the idea is that we can use the principle of relativity. And this is, for me, it's a very important principle. So maybe before we go into my theory, maybe let's talk a bit about this principle of relativity, okay? From a physical point of view. A lot of people ask me, your theory, so the name of my theory is the relativistic theory of consciousness. So people ask me, does it mean that it's about Einstein relativity? Is it about space-time, Lorentz transformations, and so on? And the answer is no, this is not about that. It's about the principle of relativity, which is the philosophical principle, you can say, in the basis of Einstein relativity theory, right? So the Einstein relativity theory is just one case of a much broader concept called the principle of relativity. And it started much before Einstein. Already with Newton, actually already with Galileo, the father of our modern science. He already noticed that you cannot distinguish between someone that moves with constant velocity and someone that will be stationary, that does not move at all. All physical experiments that we can do will not show us any difference between the two. So if we try to use physics, we try to use experiments, we cannot distinguish between them. For example, a canonical example, let's say that I take this paper ball and I throw it in the air, it will go back to my hand. So I'll say, okay, great, I'm stationary, right? But then a friend of mine can do the same experiment on an airplane that moves with constant velocity, he will also throw something in the air, and it will also go back to his hand, right? Because of inertia. Objects moves, continue to move with their constant velocity, so it will go back to his hand as well. So he will conclude that he is also stationary, right? So this is an example. So Galileo understands, there is something interesting here. There is relativity here. There is no one absolute answer for the question, what is your velocity? It depends now on the observer, on the frame of reference of the observer. So the observer will always measure that they are at rest. And other observers may be, going backwards or something like that, right? So this is the first case of relativity. So the principle of relativity states that there's no absolute frame of reference. And because there's nothing absolute, we left with observers. What the observer measures defined reality, defined the physical properties. So if we have two systems with two observers, different systems, but both of them do experiments and see that all the results are the same, then we cannot distinguish between them. They are equivalent. There's no absolute property somewhere that can distinguish between them. If we did all the measurements that we can do, in principle, we did everything that we can, all kind of experiments, and all the results are the same. So it means that they have the same laws of physics, and they are just equivalent. And this is exactly what Galileo understood. Both me as a stationary observer and someone on the airplane that moves with constant velocity, both of us will measure the same physics, the same results, that we are at rest. And that's why we are equivalent and we cannot be distinguished. And that's why there's no absolute property that can distinguish between us, right? So if we ask, who is right here? Who is really, at rest, and who is really moving? Because when I see my friend on the airplane, I will say, hey, you are moving. But he will say, no, I'm at rest, you are moving, right? So who is right? Both of us are right, because it's relative. There's no absolute answer here, right? So Galileo started with this principle of relativity. But then there is another important part of this relativity, which we call relationalism. Now, relationalism means that the properties that we see around us, the physical properties, they are not absolute as well. They are a manifestation of the relation in the system. So let me give you an example what I mean by relationalism. In the days of Newton, there was another genius, another huge mathematician and philosopher, Leibniz. Now, Leibniz and Newton argue between them about space. If space and time actually, are they absolute or relative?
Mm-hmm.
So Newton thought they are absolute. Leibniz thought they are relative. So in his mind view, he saw space and time as something relational and not absolute. Because we have objects, the relations between the objects manifest space. Relations between events manifest time. Okay, so this is an example for relationalism. If Leibniz is correct, then space and time are relational. They are not absolute. They they are manifested because of relations between the objects and relations between events. Now, we don't know, by the way, if Leibniz is correct. Like, is space relational or is it absolute? It's still under debate. So, for example, Newton thought it's absolute, and he had a good arguments for that. Einstein showed us that actually space and time relative to the observers, but still, in his general relativity, space has some absolute, absolute property as well, because you can have space and you can have curvature, even if you don't have any energy, momentum, or mass, and still you can have solutions for his. Exactly, even without space-time can have curvature. Exactly, the 4 dimensions. It can have curvature even if you don't have any energy, momentum in the universe. So is it relational? Now it seems like absolute all of a sudden. So it's still debatable, but in any case, the principle of relativity goes hand in hand with this relationalism, and Einstein had another excellent example for the principle of relativity and for relationalism. This is his equivalence principle. I think it's a very important example. So let's go into it before we go to my theory.
Most of my best ideas don't happen during interviews. They come spontaneously, most of the time in the shower, actually, or while I'm walking. Until I had Plod, I would frequently lose them because by the time I write down half of it, it's gone. I tried voice capture before, like Google Home, and it just cuts me off in the middle. It's so frustrating. Most of my ideas aren't these 10-second sound bites. They're ponderous, they're long-winded, and I wind around, they're discursive, they're 5 minutes long. Apple Notes, even Google Keep, the transcription there is horrible. But Plod lets me talk for as long as I want, and there's no interruptions. It's accurate capture. It organizes everything into clear summaries, key takeaways, action items. I can even come back later and say, hey, what was that thread I was talking about regarding consciousness and information? In fact, this episode itself has a Plod summary below, and I'm using it right now over here. My personal workflow is that I have their autoflow feature enabled, so it sends me an email anytime I take a note. Look, the fact that I can just press it and it turns on instantly, like right now it's starting to record without a delay, is extremely underrated. This, by the way, is the Note Pro, and then this is the Note Pin. I have both. Over 1.5 million people use Plod around the world. If your work depends on conversations or the ideas that come after them, it's worth checking out. That's plod.ai/TOE. Use code TOE for 10% off at checkout. Before you go to your equivalence principle, the reason your theory is titled relativistic consciousness or relativistic theory of consciousness is not because of special relativity, but because of the guide that allowed Einstein to come up with the theory of special relativity, which is thinking relativistically. And then another guide Einstein used now for GR, for general relativity, was the equivalence principle. So you're going to talk about that. But both of those were guides for Einstein to develop physics theories. And you're not looking at the physics theories and then coming up with consciousness theories, although you do want them to comport, but you're looking at what guided Einstein and then being guided by that, but in the consciousness realm.
Exactly. To be even more exact than that, what guided Einstein was the principle of relativity, as I said before. And out of that, in order to show that relativity still holds, this relativity that all inertia frames of reference are actually relative to each other, are equivalent to each other, he developed special relativity, and then he continued to develop general relativity. But in order to develop general relativity, he needed to use the equivalence principle. So the equivalence principle is another example for the principle of relativity. Now, I think, by the way, that the principle of relativity is a very basic and important principle in order to understand the reality. I think that we only scratched the surface, let's say, about the principle of relativity, and we can use it much more in order to explain most of the deep mysteries and questions that we have today in physics. Not only consciousness. So, for me, it's only the beginning. Consciousness is one example of how we can use the principle of relativity, right? So for me, like the name of your podcast, The Theory of Everything. So for me, the principle of relativity is like the principle of everything. This should guide us in order to go to the theory of everything.
Interesting.
Right? So my theory about consciousness is also guided from this principle of relativity. And later on, I plan to continue, and I'm writing papers that will be published about the quantum measurement problem and other interesting questions, and how the principle of relativity can help us there, right? But now let's go back to Einstein and the equivalence principle, and let's see how I used it to understand consciousness. So in 1907, Einstein realized, he described it as his most happiest thought of his life. And this was this equivalence principle. He understood that we cannot distinguish between system under acceleration and system under gravitation. You have, again, relativity over there. So, for example, let's say that I'm here on Earth, and I will take, again, this tissue paper in my hand. Luckily, I have this tissue paper here.
Okay.
And when I release it, it will fall because of gravity. Now, let's say that my friend is an astronaut. She is out of space, far away from every planet, every star, so she doesn't feel gravity at all. And now she is accelerating, let's call it accelerating upwards towards, the ceiling of her spacecraft. And now she's doing the same experiment. She releases this tissue paper from her hand. And the question is, what will happen with that? Because she's accelerating upwards, and she released the paper, so now the paper continues with the same velocity that the spacecraft had before she released it, right? So it will continue with the same constant velocity, while she and the spacecraft continue to accelerate. So gain velocity, right? So from her point of view, she will see how this paper goes down and down and down until it will hit the floor, right? Exactly what would happen if she would be under gravity, under the influence of gravitational force. So Einstein realized here that you cannot distinguish, that all the experiments that we can do will not distinguish if we are under acceleration or under gravitational force. So we have here again a form of relativity. Now, let's say that there is another astronaut that look at her, at my friend, at how she accelerates. And now if they don't know about this equivalence principle, they start to argue between them. he will say, hey, you are accelerating. And she will say, no, I'm not. I'm stationary. I have here gravitational force. And again, who is right? Both of them are right because it's, relative to the observer, to the frame of reference that we are in. But notice that now we can speak about relationalism. There is a relationalism here in the sense that for her, in her frame of reference, the relations that she measures manifest gravitational force. For the astronaut outside of her spacecraft, what he measures, manifests just accelerating spaceship with no gravitational force, right? So we have two different physical properties that were manifested because of different relations that, that those frames of reference can measure. So this is, I think, a brilliant example for both relativity and relationalism.
And now how this relates to consciousness.
Okay. It can help us with two major problems. The first problem is, how can we get into physics different perspectives? Because in consciousness, we know that we have different perspectives. We have your perspective, my perspective. We have the first person, third person perspectives. Now, using relativity, we see how we can implement those perspectives. Now, those perspectives will be different frames of reference. For that, I defined a cognitive frame of reference. So just one note here, a frame of reference, usually in physics, a frame of reference means a coordinate system, where is the origin of the coordinate system? For you are the origin. For me, I'm the origin of the coordinate system. So those are different frames of reference. Now I take this definition to be too narrow. A frame of reference is any observer, actually, that has causality relations, so it has causal power with the world, and the world has causal power with him. So, for example, an electron is also an observer, also a frame of reference, because it has causal power. It can influence a proton, for example. Okay, and the proton influences back on the electron. So that's why an electron is a frame of reference and an observer. And also the proton is a frame of reference and a different frame of reference, right? And a different observer, right? And now, you, as a person in space-time, you have your own origin of, where is the origin? And from this origin of your own space-time, again, you have causal power. And that's why, to speak about coordinate system as frame of reference it's fine, but it's only, a special case of frames of reference, okay? Frames of reference for me are any entity that, has some causal relations, okay? So now we can define cognitive frame of reference, because if we take a cognitive system, and again, a cognitive system means it's a system that can learn, it get inputs, represent the world, do some manipulations, and create outputs, okay? So this system is a frame of reference now because it has causal relations with the world. It can do something in the world, and the world can do something, back to this system. So a cognitive system is another kind of frame of reference, and I call it a cognitive frame of reference. So now those cognitive frames of reference are you can think of them as having different points of view, if you like, because they are different observers. Of course, nothing about consciousness yet. Yeah, for now, it's just how it can help us, maybe. So it might help us with that. It might help us to find, how to implement in physics different points of view. It can also help us how to create new properties with relationalism. So now, in order to have physical properties, I need to measure relations, and those relations will manifest different properties for me. So maybe we can find what are those relations that create phenomenal properties, and then phenomenal properties will be actual, physical properties, right? So this is why it can help us. Those two properties of, relativity and relationalism. So in my first paper, I try to show that it's plausible, the hard problem might be not so hard. There is a plausible way how to explain consciousness using relativity and the principle of relativity and relationalism. But now I finished writing my second paper, and soon I hope I will submit it and publish it. And over there, I try to build the actual case of what kind of relations we need to measure in order to manifest phenomenal properties or consciousness or qualia. I know all those fancy names for something that is like.
Okay, so let me see if I got this correct. The hard problem of consciousness, which is why do physical processes produce subjective experience at all, or as I said earlier, that no physical law or equation seems to entail that system produces subjective experience, that to you comes from a false assumption, the assumption that phenomenal consciousness is absolute.
That's true.
So observer independent.
Exactly.
So then you say a system is supposed to be thought of relativistically. A system either lacks phenomenal consciousness or has it with respect to a cognitive frame of reference.
Exactly. This is correct. Just as with velocity, if we ask the two persons, one on the ground on a station and the other one on a train, and we ask them who is correct here, who is moving and who is stationary, it seems like that they contradict each other. The one will say, I'm the resting one. The other is the moving, right? But the other will say, no, I'm resting. But actually, it's fine because it's relativistic, right? It depends on the observer. So you can have opposite properties with relativity. Interestingly, this is exactly what we are stuck in when we think about consciousness with the explanatory gap. Because let's say that I try to find your phenomenal consciousness. I will not find it in your brain. I will only find neural patterns. So I will conclude that you're just a philosophical zombie. You don't have any consciousness at all. But I, of course, have consciousness. I have all those experiences. But then, of course, you will say the opposite. You have you have your own experiences, so you have consciousness, and you don't find my own consciousness when you look at my brain. So we have here again like a contradiction or opposite properties. But again, if we think about it from a relativistic point of view, then it makes sense. Because from my cognitive frame of reference, I measure that I have consciousness, but I cannot measure that you have consciousness. And from your cognitive frame of reference, which is different, you measure that you have consciousness, but I don't have consciousness, right? So all of a sudden, it makes it much more plausible. We can understand how can it be that we have this seemingly contradiction.
Mm-hmm.
You see, so this is the starting point of the argument, and we don't need to go to illusionism like Dennett did, for example. Illusionism, we don't need to go to illusionism anymore, because illusionism is to say that we privilege one kind of cognitive frame of reference. We privilege the third person frame of reference, but we don't need to do it anymore. Now we understand that with relativity, we understand that it's wrong to privilege one frame of reference. All frames are equivalent. It's just a matter of which frame you are in, and we can do transformation from one to the other.
The Economist covers math, physics, philosophy, and AI in a manner that shows how different countries perceive developments and how they impact markets. They recently published a piece on China's new neutrino detector. They cover extending life via mitochondrial transplants, creating an entirely new field of medicine. But it's also not just science. They analyze culture, they analyze finance, economics, business, international affairs across every region. I'm particularly liking their new insider feature. It was just launched this month. It gives me a front row access to The Economist's internal editorial debates, where senior editors argue through the news with world leaders and policymakers in twice weekly long format shows. Basically, an extremely high quality podcast. Something else you should know about is that if you go to their app, they not only have daily articles, but they also have long form podcasts with their editors and writers. This is also available online. Whether it's scientific innovation or shifting global politics, The Economist provides comprehensive coverage beyond headlines. As a toll listener, you get a special discount. Head over to economist.com/TOE to subscribe. That's economist.com/TOE for your discount. All right, now we've set the stage, and I have a variety of questions.
Okay.
So firstly, let me see. From a first-person frame, a cognitive system observes that it has qualia, but from the third-person frame, you just see the neural substrate, so that's the easy problem. And that neither is more fundamental or privileged, as you said. So Angelina, who's on the platform, observes Brad on the train, and it's not that Brad has the true velocity and Angelina is truly at rest. It's that none is privileged. Okay, allow me to push on this relativity analogy. So in special relativity, there are transformations, certain transformations that you could do to compute precisely what everyone else will measure from where you are, from your own measurements. So there's a transformation there between the first person or the observer's frame and then the third person. But in yours, it's, as far as I understand, just a delta function or something like that. So same frame will give same measurements. It's the identity. It doesn't predict anything new. So I'm wondering, I could be wrong, what is the relativity in your framework actually doing here besides serving as a metaphor?
The fact that you cannot measure from the outside that I have consciousness doesn't mean that we cannot calculate or we cannot do a transformation to my frame of reference, right? Exactly as Angelina doesn't measure that Brad has that Brad is stationary. Still, right? If we do the transformation from her frame of reference to his frame of reference, all of a sudden, because of this, the law how to do this transformation, we will see that now Brad measures that he is stationary. Okay? Same thing happening here. I developed a transformation so we can start, let's say, from my cognitive frame of reference, where I measure that I have consciousness, but you don't. And then the rules of this transformation will preserve that when I do this transformation to your cognitive frame of reference, all of a sudden you will say, I have consciousness, or you will experience consciousness, but you will, when you try to find you will measure that I don't have consciousness, right? So this is exactly part of why relativity is so powerful. We can create those transformations from one frame to the other, and if those transformations are good enough, then we get exactly what you will measure, right? So it's and then again in my first paper, this is exactly what I try to show. Now, another thing about that in physics, in order to say that something is relative, or it means that, as we said before, when we take those two frames of reference, they are equivalent, so they have the same laws of nature. So it means that if I do a transformation from one frame to the other, same laws should exist. So the equations that describe these laws should be the same, right? We call it invariance. So the laws of physics should be invariant under transformation of under frames transformation, right? So this is exactly what I showed in my first paper, that I defined those cognitive frames of reference. I defined how to do the transformation between them and show that those transformations are invariant, and preserve preserve the equation, of this transformation, actually. And then after the transformation, it will describe what you will measure and not what I will measure. Okay.
Sure. In special relativity, the transformation is a Lorentz transformation. What group or what transformation is it to transform between a cognitive structure and then a consciousness, first person structure, and then a third person physical structure?
Yeah, this is a very good question. Lorentz transformations are continuous transformations. It's a continuous group. And in my case, it's not. So it's over there, it's continuous group because it's about space and time, which are continuous. But here, it's not continuous anymore. It's a discrete group. Because now it's discrete, we move from one frame, cognitive frame, to another cognitive frame. So it's a discrete group. Now, over there, in Lorentz transformation is also, how do they call it, non-compact transformation. It means that you can reach infinity.
Mm-hmm.
It's the limit case when you go to the speed of light. Here, we don't have any, case of infinity or something like that. So it's much easier, let's call it, transformation. It's discrete, it's compact, and, it's abstract. It's much more abstract than, the group, the Lorentz group. So the thing here is that I'm not familiar with any name that describe this kind of a group. It will be a good idea to ask mathematicians, to ask mathematicians that are specialized in group theory. Maybe they know which kind of group is it. But at least I know it's a group. And how can I know it's a group? Because in mathematics, in group theory, we have specific conditions in order to be a group. And my transformation meets those three conditions. So the first condition is a closure, that, this transformation always creates a new frame of reference, a new cognitive frame, and you can always, you always stay inside this system of cognitive frames of reference. And the second condition is that there must be an identity element. So like that if you use this element on the frame of reference, you stay on the same frame of reference. That's why it's an identity. And then The third condition is that you will have an inverse element. So, for example, let's say that I start with my cognitive frame of reference and do a transformation to your cognitive frame of reference. Now I can use the inverse element in order to go back, to the frame of reference that I started with. So again, I show how those three conditions are met with this transformation. That's why I know it's a group.
So there's a mapping between a first-person observable and a third-person one? And is there some invariant quantity that they'll all agree on? Like in special relativity, you have a space-time interval. Is there something else that they'll all agree on?
Yeah, not exactly. Notice that, so we used to think about relativity theory, Einstein relativity theory. So we used to think about, the need for some anchor, like the speed of light. But let's take Galilean relativity. Over there, we didn't have any anchor like the speed of light or something like that. So it's not part of the definition of the principle of relativity that we must have some kind of an anchor, something that is invariant all the time, like the speed of light. Maybe in the future we will find that there is something like that also with cognitive frames of reference. But for now, I didn't see it. You need to remember also that, so again, this paper, the first paper, was more about to show the plausibility of that, to show that the hard problem might not be so hard if we take into account the principle of relativity. Because then we can think, okay, now it's a bit like a coin. You have the head and the tail of a coin, and both of them are just two different sides of the same thing. And the same now with relativity and with cognitive frames of reference. So one side is when you measure my brain from the outside and you see neural patterns, and the other side is my first person point of view. But now the question is, how can we move on from to speak about plausibility and to actually show the mechanism, how it can work, how it works? Let me give you an example what I mean. Let's say, okay, two things here, two examples here. The first example, let's think about equivalence principle again. The astronaut from the outside of the spaceship and the astronaut inside the accelerating spaceship. And again, they have different measurements, right? And he will measure that she is accelerating, and she will measure that she has gravity, right? Now, reduction means if we will try to explain her gravity from his measurement of acceleration, then we can say, we did a reduction from gravity to acceleration. Now, of course, this is not the case. We don't need to do reduction here, right? Because it's just two different frames, and both of them are right, and there is no reduction here, right? We cannot do a reduction from head to tail. So we cannot do a reduction from her frame to his frame. Same with consciousness. We cannot do a reduction from me measuring I have consciousness to you measuring I don't have consciousness, from first person point of view or first person frame of reference to third person frame of reference. There is no reduction here. Okay? So this is first thing that we need to notice here. The relativistic theory of consciousness is not a theory of reductive materialism. There is no reduction here. Okay? Just two sides of the same events, let's say.
Yeah, suppose it's true. These are two sides of the same. Now, on one side of the coin is what people would associate with physics, and on the other side is what people would associate with consciousness. Then why do you say that your theory is a physicalist theory of consciousness? If no side is to be privileged, then it doesn't seem to me that you could reduce it down to physics That any argument you can make that would be reducing it down to physics, one could make to reduce it down to consciousness.
Right. Excellent question. This is the reason that it's such an excellent question is that this is exactly what I wanted to speak next. So, first of all, the short answer for your question is relationalism. I claim that consciousness is also a physical property, and it manifests just because of relations that we can measure from our own cognitive frame of reference. Those measurements, those relations are different than the one that you can do from the outside. And that's why there are different physical properties that are manifest here.
I'm confused as to why it's called a physical property. Why are you calling it a physical property and not something else ontologically, some other entity? So what's the difference here between a property and then just something else?
Okay. Another excellent question. So, if we take the principle of relativity serious enough to be a basic principle of reality, then all properties and all entities that we can see are just manifestations in a specific frame of reference. Like we saw before, gravity or acceleration and so on, right? So now we start from, not from entities, not from properties, we start from something else. We start from causal structures, from causality, actually. Something that cause change for another thing, like A changes B, right? This is causality for me. And now we have some causal chains. A changes B, B changes C, C changes D. We have those causal chains. And now different frames of reference will manifest those causal chains differently according, to the relations that they can measure. So not all frames of reference can measure the same causal structures. One frame will measure a causal structure of a spaceship that is accelerating, right? Another frame of reference measure that she is actually stationary and she has gravity, okay? So properties and entities now is something very fluidic, if you like, it's like, it's relative now. It's all relational, okay? But all of those are part of physics now. And the claim is, so I'm a physicalist, but maybe it's a new kind of physicalist that say that physics, the basic principle of physics is the principle of relativity and relationalism. And with that, we can explain everything that we see, including consciousness. So consciousness now will be part of physics using relationalism, using relativity. Okay, we just need to show which kind of relations can create this physical property that we call consciousness or phenomenal properties. So let's dive in how I try to show it in my second paper, actually.
Please. This is cutting edge.
Yeah, exactly. It's still not in the air. It's not out there, actually.
It's bleeding edge. Okay, even more.
Like I finished writing it, and now, I'm submitting it to Journal of Consciousness Studies. So I expect it to be published in couple of months, maybe half a year or something. So you're actually going to hear for the first time what, the next stage, you can say. So now we need to specify what is going on inside our cognitive frame of reference. Just to be clear, it's much easier to understand what is going on when I look at your brain. right? When I look at your brain, I need to use my sensory system, like my eyes, ears, and so on.
Let's make this intimate. Let's say when you're looking at the listener's brain or the viewer's brain.
Okay. I'm looking at the brain of our listeners using my eyes. And because I'm using my sensory system, the only relations that my sensory system measures are the substrate of the brains of your listeners. And that's why when I use my sensory system, I will always manifest the third person frame of reference. The substrate of neurons and their dynamics.
Mm-hmm.
This is, let's call it the easy part. Okay, we just need to understand that our sensory system was designed in order to catch the substrate of the world in order for us to survive. Now, what is going on from the inside, from our own cognitive frame of reference? Over there, we don't have sensory system or sensory devices. We don't have an inner eye. We don't have some kind of a device in order to see the substrate of our own brain. So this is not the measurements that we can do. These are not the relations that we can uncover over there. Those relations are completely different. And that's why it manifests a completely different physical property. And now I will try to show you that this physical property has to be consciousness, or has to be something that is like, this something that is likeness. Okay, so this is, so now I set up the frame, what we are going to do. Okay, we're going to go inside our own cognitive frame of reference, try to understand what are those relations. We know that they are very different from the sensory system. And that's why it's different from just seeing a third-person point of view. But we don't know what they are yet, right? So now let's see what they are. So in order to do that, we need to extend the principle of relativity, to extend it more and more than what we use today, and what Einstein did, in order, in the end, to extend it enough so we can understand what are the relations that manifest phenomenal properties. So in order to extend it, let's use 3 scenarios. In the end of those 3 scenarios, we will have phenomenal properties. Okay?
Phenomenal physical properties?
Yes, phenomenal properties as a physical property. Okay?
Okay.
So the first scenario is about emergence. For example, let's think about water. So water is the canonical example for emergence. In the micro scale, we have H2O, and then in the macro scale, we have water that have wetness. So a new physical property has emerged here. Or is it? A limitativist will say it's only a convenient way of describing the complexity of molecules of H2O. It's not really there. There is this kind of philosophical argument, let's say, that all there really is are just those elementary particles, whatever they will be. Maybe quarks and electrons. Is it true that it's only a convenient way of speaking? So if we take the principle of relativity, we can find an answer for this question, or an answer what is actually emergence to begin with. What I mean by that is, if we were tiny creatures that can measure the micro scale, we will not measure water or wetness at all. We will just measure complexity of molecules. Lots of hydrogens and oxygens that have
Got it.
right that have some kind of very complex interactions, but no water. So let's call it the micro frame of reference. And why we can call it the micro frame of reference? Because we assume a causal closure. Now, all the interactions that we measure show us the existence of molecules, but not water at all. That's why we have a causal closure over here. Okay? All the causal chains are just of the molecules. That's it. So all the relations that we measure manifest for us hydrogen and oxygen molecules, and no water. Okay. So this is the micro frame of reference.
Okay.
But now we can think also about another causal closure of the macro, like something like what we know from our day-to-day life. Let's suppose that we can find this causal closure where what we measure are only water. We cannot measure the actual molecules of the hydrogen and oxygen molecules. And all the dynamics, all the causal structure that we can measure about water will be only of, of the continuum hypothesis, that everything is continuous, hydrodynamical, only about the fluid mechanics, nothing about the molecules themselves. So now we can call this a macro frame of reference. And in this frame of reference, the relations manifest for us water and continuous hypothesis, fluids, all the macro properties like entropy, and so on. Okay? So it means something very interesting about emergence. It means that emergence is also a relativistic property. Because in the micro frame of reference, if you ask someone from there, they will tell you, there's nothing like water. I don't know what you're talking about. It's not real, right? And from the macro frame of reference, they will say, water are real. Molecules are weird. I didn't find any molecules at all. The elements of water are just water droplets. Okay, so now, all of a sudden, emergence is also dependent on the observer. It's not something that is absolute anymore. So this is the first scenario. We extended a bit the principle of relativity to see how emergence is also relativistic. And now, another interesting example, it's still about water. Let's suppose that in the future, we can create artificial molecules. It's not hydrogen and oxygen, but artificial molecules. But we create them such as they create the macro properties of water. So we cannot distinguish when we look at the macro properties of this artificial water, it's exactly the same like natural water, right? But the molecules are completely different. Let's say that we can do something weird like that. The philosophical question is it the same? Is it still water or not if the elements are different? And again, now we understand that because emergence is relative, it depends on the observer, right? In the macro frame of reference, when all we measure are just water, over there, the answer is yes, of course, it's water, right? It's the same. So it means something for us about emergent properties, in order to measure them, We need to be in the correct frame of reference. Yeah.
Okay, so are you calling these functional descriptions or causal descriptions? What was the word that you used?
Causal closure.
Okay, so I imagine there are several different levels that your brain tracks causal closure. It could track cells, it could track a circuit, it could track behavior from other people. There are various levels. What level of granularity is the one that's identical to consciousness? Because it sounds to me like there may be a version of the preferred basis problem, but for the cognitive frame of reference here.
Yeah.
Like what chooses the basis? You could be too coarse, you're just tracking temperature. And then you could be too fine and you're just tracking precise physical implementation of everything.
So this is a very good question, but we are still too far away from the answer from how to create phenomenal properties. It's still not about just an emergence, So you need to wait with this question a bit, because it's still not relevant for consciousness. Although I started with emergence, and it seems like, okay, it's just another, consciousness will just be another emergent property. It's not that simple. If it was that simple, we didn't need relationalism and relativity. So hold with this question a bit longer. Something else that is very important here to notice that, of course, now we are speaking from a physical point of view. It's not about perception, right? It's exactly like when we spoke about velocity or Einstein equivalence principle. It's not about perception, it's about the physical laws. So we assume that we do all the experiments that we can do, right? It's like in principle, we did everything we can. And we know about all the experiments that there are. And if there is no experiment that shows us that molecules exist, then for us, molecules don't exist, right? If the relations show us that water exists, then water exists. It's even, I said show us. So it seems, again, like I'm speaking about perception, but it's not, right? I'm speaking here about the laws of nature, about, what are the actual elements of reality. It depends now on the frame of reference that you are in, right? So in the macro frame of reference, the actual elements are the droplets, not the molecules.
Sure.
Okay? Regardless if there are humans there or not. Just to make sure, that
Okay.
That's, this is a very important point here.
And I know that you're in the middle of an explanation, but just as people are listening, they may wonder, well, why doesn't a droplet count as a conscious observer? What about an electron? So they may have that in the back of their mind that's preventing them from fully listening to the rest of what you're about to say. So can you please address that?
A conscious observer? What do you mean by a droplet as a conscious observer?
Does an electron have phenomenal consciousness? Does a droplet of water have it?
I see. So this is very good point. They don't have it. We start from purely third person point of view, from regular physics. And from that, we need to extend the principle of relativity until we can get to consciousness and phenomenal properties. So, in physics, observer has nothing to do with consciousness. It's just another word for frame of reference, as we discussed before. So, electron does not have consciousness. Water does not have consciousness. Later on, we see what are the conditions for consciousness. And then we can understand which entities can have consciousness, okay? But for now, nothing have consciousness yet. Nothing has consciousness yet. Okay. So now we can continue. So we discussed a bit about emergence. Now let's think about the second scenario. Let's take it even further away. what if we can create a simulation, even a simulation of water to begin with? And now we cannot distinguish between the simulation of water and regular, natural water. What's then? Will we say that the simulation of water is the same like the regular water? In order to do it even more accurate than that, let's assume that we can create a simulation of the universe, not only of water, okay? Because, water has so many causal interactions with other stuff. So let's just take all the causality that there is. Let's say that we are in the future and we know how to do it. We know about the theory of everything.
Okay.
Curt is out of job. and we create a simulation. We code all the equations, hit the run, the enter button, and let it run. Okay? So now, in this simulation, the question is it real? Can we say it's real like our real world, or is it just a simulation, right? Now, according to the principle of relativity, again, we can think of another causal closure. Now, this causal closure will be about the causality within the simulation. What I mean by that is, in order to create a simulation, it means that our computer has now has now all those equations running. So it has variables. Some states of the computer are the variables of the equations, and those states are changing. This is how the variables are changing, right? So we have now states in the computer that carry information, carry content about those variables. Okay, so now I can find a new frame of reference where those variables, those are the causal chains that I measure. Okay, how the variable changes, I don't know, in the equation of gravity, how the variable changes in the equation of electrons, and so on and so on, right? So now I found this new frame of reference where everything I measure is just those variables and those causal relations. So according to the principle of relativity and according to relationalism, now those variables are the manifested physical properties, and they are real, exactly like our own real world. We, in our own real world, measure causality and it manifests entities and properties, but also in the simulation, in this frame of reference of the inside of the simulation, the causalities over there are those variables, and now they are real. Now they will be our physical entities and properties. And because we put the equations to be exactly like our universe, then the simulation is real and is exactly like our universe in the frame of reference.
Okay, so if something has causal efficacy, then it's real.
Yes, exactly. If you remember, we discussed before that if we take the principle of relativity to be the basic principle of reality, we start, our elements now will be causal chains.
Okay.
And different frames measure those causal chains, and according to these causal chains, entities and properties will be manifested, like acceleration or gravitation and so on. So now I extend it.
Am I to understand that if something is real, then it is also causal, so that it's an if and only if statement?
Yes, exactly. According to the principle of relativity, again, something real is something causal, something that has causal relationship, let's call it, with other entities. If there is something that has no, so if we choose a frame of reference, first of all. In this frame of reference, if there is something that has no causal power at all, and nothing change it, so no causal relations at all, then it cannot be measured. And then, because of that, it doesn't exist. It doesn't manifest in this frame of reference. It can exist in a different frame, right? Okay.
Yes. Okay, I have a quick question. So we're in this universe. Conceivably, there's another universe that is causally disconnected from ours. In fact, there are many theories of physics which posit such universes. And even in principle, not just in practice, but in principle, in some of these theories, we can never know about this other universe and they can never know about us.
Yeah.
I would still say that if those theories are true, that those other universes exist and they exist to us and we exist to them. It's not just it's not just we exist to them and they exist to us, or we only exist to ourselves or something like that. It's that they exist and we exist.
Yeah.
But according to this, you would say, no, what is real is observer dependent, that our universe is real to us, and that's all we could say?
It's more than that. What I would say is that we have most likely infinite number of universes, each of which has its own causal closure, its own bubble of reality, I like to call it. So for us, our bubble of reality is real. For them, their own bubble of reality is real. But because there's no absolute frame, we cannot privilege our own frame. So we cannot say that only us is the real bubble. And they cannot say that we are not real because only they are the real bubble. Right? So everything exists. So we got now like a reality according to this principle of relativity. If we take it, far enough, it will say that reality composes of all those infinite number of bubbles. All of them are real, right? But it's relative, right? They are real because there is at least two observers. There are at least two observers that can, measure each other, and they have this causal closure, and that's why, it's a real bubble. It's a real universe. Okay, so we
Okay.
So each bubble exists because of the measurements from within. Let's call it. So this is the idea, and one of my papers, my next papers, will show that one of the results of the principle of relativity is that the vacuum cannot be empty. The vacuum cannot be empty. It must contain all those different bubbles of reality. It cannot be the case that only us exist, only this bubble. If it was the case, then it was an absolute property, only us exist, right? So if we take the principle of relativity to be a basic principle of reality, the vacuum, what we cannot measure, actually full with all those different universes, different bubbles that we just cannot measure them. Okay, so this is one of and then I show it. I show it mathematically, and this is what I will show in my third paper, more or less. So
Okay.
right now I don't remember what was. How did we reach this question? What did you ask?
Well, I was saying that what disturbs me is that much of this framework, from what I recall from reading your paper, is that a cognitive frame of reference is defined by the dynamics of the system. And then I was wondering, well, at what scale does a single neuron get a cognitive frame? Does my cortical column, or one of them, or my left hemisphere? And if there's no principled way to draw that boundary, then how do we know what is conscious and what's not? To the physicist listening, there's a preferred basis problem. In physics, it seems like there's a cognitive preferred basis problem or frame problem.
This is a very good question. So your question is actually from an absolute point of view. You try to understand absolute answer here to get an absolute answer, which scale is the correct scale. But what we saw with the emergence scenario and with the simulation scenario, actually, is that we need to think from a relativistic point of view. And then what matters are the causal relations, as you said before. To exist is to have causal relations. So one neuron exists because it has causal relations with other neurons in the brain and other stuff, right, in the brain. Cognitive system also exists. Now we need to remember what is a cognitive system. And one neuron most probably is not a cognitive system just because of our definition. Our definition is that a cognitive system is a system that, can get inputs, learn, create representations, do information manipulations, and create outputs out of them. If a neuron can do that, then one neuron can be cognitive system already. If one neuron cannot do it, then it cannot be a cognitive system. Let's suppose that it cannot do it. Let's suppose that we need a bunch of neurons. Now this group or set of neurons, they together, they have causal power, they react to the world and the world reacts to them as well. So that's why now they are a new entity. Okay, according to relationalism, this is now a new entity. And that's why for this entity I call a cognitive frame of reference. No consciousness. Notice, no consciousness yet. It's just about a learning system. Okay? But already we know, from the example of water, for example, that there is an emergence here of a new entity, even though it's not about consciousness yet. Okay, so we call this entity a cognitive frame of reference. Okay? Now we need to continue because we are still not, we didn't reach our destination. We didn't reach phenomenal properties at all. But we did some, some steps towards it already. And let me show you why we did some steps. The last scenario that I described was about the simulation and how we can choose an intrinsic frame of reference inside the simulation, right? In this intrinsic frame, they will, let's say that someone, that there are humans over there, right? And I somehow can communicate with them and I ask them, what do you see? Again, not about consciousness, okay? I don't want people to be confused here. But let's say, what's inside the simulation? What do we see in this frame of reference? And, the measurements are measurements of everything that we see here in the universe. They have stars, they have gravitational force, electromagnetic force, and so on. But for me, I'm from an external frame of reference. I see a computer that runs a simulation. I just see a code. I don't see stars inside the computer. I don't see gravitation inside the computer, So it seems if I don't know about relativity, if I think everything is absolute, it seems like that there is an explanatory gap here, because from the inside of the simulation, they have stars and gravitation, but from the outside, from the external, I don't see them, and I cannot understand how entire star, with huge mass can be inside my computer. How can I do a reduction here? It doesn't make any sense, right? So there is we created an explanatory gap here. Not because of consciousness, just because of this weird situation with the properties inside the simulation and outside the simulation. But it's only a seemingly explanatory gap, because there is an explanation here. There is no gap. The explanation is relativity, the principle of relativity, and relationalism. From the outside, I measure the substrate of my computer and then I measure those electric current that moves in the logical gates. And as part of those states that are moving in my computer, they have some content about the variables of the equations. Okay? So it's a very complex causal structure here. Some of the causality is about the electricity, right? Some of the causality is about the equations, the variables of the equations. But the variable of the equations is just one, let's say, has some causal power, but very small causal power in my frame of reference. It doesn't, those states, those variables doesn't change, for example, the location of the currents inside my computer. It does some work, let's call it, because it changes the equations, the states. But it doesn't do a lot of work. It doesn't change the electricity movement, inside my computer. Okay? So from my frame of reference, this is what I measure. Just a computer runs some algorithms. But from the inside, from the frame of reference of the simulation, the measurements are completely different. Over there, all they can measure are only those variables. So the variables now has much bigger causality, causal power, than what I can measure from the outside. Over there, the causality is exactly what they do in the equations, how they change other variables. And because of that, of those relations, all of a sudden, over there is a manifestation of a space, a manifestation of stars, of gravity. Okay, just because they have much less complex causal structure. All the causality over there is just because of how the variables interact with each other in the equation. That's it. No causal structure of the substrate, of the electricity and all that. And that's why, because it's such a narrow causal structure over there, the properties and entities are so different than what I measure from the outside, and that's why they actually measure stars and electricity and gravity and so on. So now we have an explanation. There is no gap anymore. There is an explanation why we measure such different properties in the intrinsic simulation frame of reference and the extrinsic frame of reference, of where I see the computer. I think it's a very deep point, because we actually created here like an artificial gap, explanatory gap, and but according to relativity and relationalism, we can bridge this gap, right? And if this is understood, then we can take, it means that we did some steps towards understanding how to bridge the gap with consciousness.
Okay, let's get to how consciousness has any bearing to cognitive frames.
Okay, so now we finished with the second scenario, and we saw how, there is a seemingly gap, and we bridged it. So it can give us some hope that on the same way we can bridge the gap, the explanatory gap of consciousness. Okay, so for that now, finally we have reached the third scenario. So now we can use the same tactics. We saw how a simulation can create or can manifest completely different physical properties and entities than what we measure from the outside. So let's use that. Maybe our brain creates its own simulation. Maybe we are stuck in a matrix, if you like. We are stuck in our own intrinsic frame of reference, our own intrinsic simulation. What we measure inside the simulation, again, are the variables of the simulation. And again, those variables now will have all the causal power, and that's why those variables now will be the physical entities and properties. Now, it makes sense, actually, that the brain will create a simulation. Because the brain needs to do two things, actually. It needs to understand now what is going on now, what do I see, what do I hear, and then also to predict, after understanding what is going on now, to predict what will happen next. In order to do that, a simulation is a very good idea. If you have a simulation, it means that the cognitive system understood the structure, the causal structure of what is going on here, and then it can predict what will happen next. So that's why it makes sense from an evolutionary point of view, from a neuroscience point of view, that the brain will create this kind of simulation. It gets inputs from the outside world, the external world, build representations of those, of this external world, and learn slowly, step by step, what is the causal structure of the external world, and can create a simulation of the external world inside our, cognitive system. But we need to remember, of course, that the simulation tries to mimic the external world, right? We have the constant flow of information, of inputs inside, and those inputs, I can say, dictate. Those inputs dictate, the simulation, what is going on in the simulation, right? So it's an interesting scenario where we created a simulation that tries to mimic the external world. But again, from, within the simulation, in the frame of reference of the simulation, all those variables, have all the causal power. So they will be the entities. But those variables are exactly what we are mimicking from the outside world, right? So the simulation actually mimics all the entities in the simulation are what we see outside. Trees, stars, other humans, right? Gravity and so on. So we actually created good enough simulation, good enough for us to survive, a good enough simulation of the external world in our cognitive system. So now, but again, we need to remember that the fact that now I see you in my computer, and the fact that now all of the audience actually can hear us and see us, it's because we have a simulation. They have a simulation in their own brains. And this simulation has variables that are mimicking, the external world. So all those, in this simulation, they have variables, that mimic me, for example, and mimic you, for example, mimic the sound, right? And that's why all of those are now manifested as real properties in the simulation of your audience, and in my simulation, in your simulation. Okay? So, but it's still not enough. It's still not consciousness.
Okay.
Because for consciousness, we need something that is like. What is this something that is like? It's a new variable. It's a variable that each of us has, in our simulation. This variable comes from the question of when I get an input, is that input good or bad for the system? For example, I see a lion. Is it good or bad for me? Right? I see a fruit. Is it good or bad for me? We call it affective valence in neuroscience. No, okay, so this is it's like a spectrum of answers, like from 1 to 10, you can think about it. 1, very bad, 10, very good, right? In like a spectrum. And so this is another variable that we have now in the simulation. So when now I simulate the outside world, I simulate all the inputs from the outside. That's why I can create, the outside world intrinsically inside the simulation. But now I have another variable that is not out there. Variable that just, my cognitive system uses to understand if the inputs from the outside are they good or bad for me. Now, so for example, when I see an apple, this apple now will have all the properties that are coming from the inputs from the outside, like the frequency of it, the shape. But it will have another property, the property of is it good or bad for me? Okay. Now this property is also being manifested just like all other variables. So these variables are now manifested in the simulation as yet another physical property. You see, now this physical property is exactly what is it likeness? What is it like for me to have the apple? It's very good for me. For example, what is it like to see a lion? It's not good at all, right?
Let's dial it back. I want you to repeat that part. So a simulation looks at all the actions it could take and all the objects in the scene or what have you, and then suppose it labels them. Sorry, I'm a bit sick. Speaking of redness, say it looks at the redness of my nose. Okay. And it says that's neutral to me, or maybe that's negative to me. I don't want to get sick. Okay.
Right.
It labels that. Go from there, from that labeling of good, bad, neutral, or what have you, to then the felt like again.
Okay. So we need to remember here two things. One thing is that we have the variables, and then the variables manifest as a physical property, right? Inside the simulation. So now let's say that my cognitive system gets an input of an apple. And my system learned from the history, from my history, that an apple is good. Is a good thing for me. It's good food. So it will so this variable of affective valence will label the apple as good. This is good for me. Now my cognitive system knows that if the label is good, then I should do some outputs in order to get this apple. For example, I can reach my hand and pick up the apple. Okay, so effective valence is a variable that is very important for the cognitive system. It has a causal power, on my cognitive system. If it's good, I will react. I will try to get some more apples. If it's bad, like very bad, I don't know, I see a tiger, then again, it will cause my cognitive system to react by running. Run very fast. Okay?
Okay.
Now but now we know that this variable will manifest inside the simulation as a physical property. And it's a physical property of the apple, right? The apple now has a property of is it good or bad for me? The tiger now has a property. Is it good or bad for me? Everything has a property now, a physical property of is it good or bad for me?
Okay.
Okay, this physical property is exactly what is it like? What is it like for my cognitive system to see an apple? It's like something good. It's good for me. Okay, what is it like to see a tiger? It's like something bad for me. Okay, this is how we start. Like we start from something very, very basic. But now, notice, or you know what? Another example. With time, we can create more elaborate affective valence. For example, when I see a fire, if I go and touch the fire, it's very bad for me. So affective valence will say, oh, bad, right? But then I'm a bit cold, so when I go near the fire, all of a sudden it's good for me, right? So I have here this spectrum or more complex affective valence. It's bad if I touch it, it's good if I near it, and so on. Okay, so I have a complex, again, causal structure here of, how good is it for me? How bad is it for me?
I just have a quick question. So
Yeah.
you pointed out something interesting. Most of the time people will say tiger, bad, and then apple, good. But you just said some of it's contextual. Even the tiger itself is bad when it's biting you, but then
Yes.
it's good if you're behind it and you're just going to hit it with a spear because then you get to eat.
Exactly.
Same with the fire. The fire is bad if you touch it and keep your hand there. The fire is good if you're close to it for warmth. It could even be good if you're touching it to cauterize something. So
Exactly.
I imagine that phenomenal experience, which we haven't yet gotten to, but I imagine that phenomenal experience is far richer than simply a single good, bad axis.
Right.
So are you just right now saying that the beginnings of phenomenal experience are where the seeds of good and bad lie?
Yes.
Just this unidimensional first.
Exactly. The consciousness starts from a very basic experiences of good and bad. And then because of learning and context, it become more and more complex, elaborate, more and more we can have new feelings that will cope better with this complexity, for example. So it starts from very rudimentary consciousness, let's call it, and during our life and experiences, we can get a much more elaborate consciousness. Now, you asked about the phenomenal properties. So this is exactly a phenomenal property now, because now for each entity that we have in our simulation, may it be an apple, a grass, I don't know, or my grandma, all of them has all the regular physical properties, but also a physical property of what is it like to have it. And what is it like? This what is it likeness starts from a very rudimentary, good for me, bad for me, you know. And with context, it will become more and more elaborate. Now, what is this context? This is exactly more causal relations, right? More causal relations. Fire can hurt me, but it can warm me up, right? So I get more causal relations into the simulation. And again, those causal relations are exactly what manifest the properties, right? So it will manifest this what is it like property, which will be more and more elaborate, I guess I will call it, as I have more and more causal relations, attached to it. So now physical properties are actually a physical property. Okay, this physical property is exactly like any other physical property inside my simulation. Okay, so in the simulation, again, from all the causal relations, the shape is manifested, but now also from all the causal relations and affective valence, this property of what is it like, is it good or bad for me, also is manifested. Okay, so just another physical property now, but again, only in a frame of reference that is inside my simulation. Right? From the outside of the simulation, you can only measure my substrate. You can only measure my neurons and my brain. Right? So you cannot measure what I can measure from the inside of the simulation. Exactly like in the previous example, right? Inside the simulation, they had like stars and everything. Outside, I measure on the computer that runs some algorithms. Also here, from the outside, you measure that I have neurons with some dynamics, but from the inside, I'm inside the simulation and I measure, all those variables as the actual physical properties. Okay, and one of those variables is effective valence.
I imagine David Chalmers would say something like, okay, so you have a simulation. On the outside, you can look at the simulation like your CPU or your hard drive, and you just see zeros and ones and they're running. And then you could go from the inside of the simulation and you can observe, although that's a loaded word at this point, causal relationships differently. But then the question is, why is it that being on the inside of a cognitive frame turns information processing into something that's felt? It seems that what you've done is restate the hard problem using new symbols rather than solved it. So where's Chalmers going wrong here?
So it's funny to say, well, Chalmers is just wrong.
Or my simulation of Chalmers is wrong.
Yeah, the simulation of Chalmers is wrong. Let me think for a second. We started from give some kind of definition of what is consciousness and what is the phenomenal consciousness is, right? And it was, if you have something that is like. But now we didn't know how something that is like can be part of physics, can be an actual property of a physical entity. Okay? But now I actually showed you a way how we can do it. We use relationalism, right? If you remember how we started from the point that I made that relationalism now can manifest new physical properties. we just need to understand what are the relations to manifest phenomenal properties, right? And then it will be a physical property, right? Because any physical property is a according to the principle of relativity, every physical property, like gravitation, is just a manifestation that was measured, like relations that were measured. Like in the spaceship, the relation manifests gravity, right? Now, here, we see that we have a frame of reference intrinsic inside the simulation. And it manifests all those variables of the simulation as real physical entities. Now, one of those variables gives me something that is like. It gives me, something that I cannot find out in the outside world, right? In the outside world, the apple has some kind of a shape, some frequencies, and so on, amount of sugar, right? It doesn't have a property of, is it good or bad for me? So now, inside the simulation, I added a property that you cannot find in the outside world. And this is exactly what is it like? What is it likeness? Is it good or bad for me? This is the beginning of what is it like. So that's why now, what is it like? This phenomenal property is just like any other physical property. It's just manifested because of relations, the relations that I can measure in the simulation. Does it make it a bit more clear?
This is not different than functionalism. The difference is that you're deriving functionalism from something more primitive. Is that correct?
No, it's true that I derive here functionalism, or at least I derive here the most prominent result of functionalism, which is that the substrate is not important. They will say that function is what important, right? But what is function? It's just, the causal relations. So in the end of the day, it's the same, it's the same like what I try to say. But I say as you said, I started from physics, from the principle of relativity, right? And because of the principle of relativity, because it starts from causal relations, and then frames of reference manifest entities and properties out of those causal relations, it means that, the substrate is not really important. What's important are only the causal relations. If we have two systems, and the two of them measure the same causal relations, then, they're equivalent. Then they will, the same physical properties will be manifested there. It's very important to give you an example, for the audience. It's exactly what we saw with the emergence of water and artificial water, if you remember. We have two different systems, because they are different because of the artificial molecules and the real molecules, right? But both of them create the same causal structure of water. So they are the same, they're equivalent. Both of them will manifest water, right? This is it. So the substrate is not important anymore, like in functionalism. But the difference here is that in functionalism, you don't have this manifestation, right? You don't have this way of creating new physical properties. In functionalism, it's a bit like illusionism. It's a bit like to say, it's just a function. It's just another way to describe it. It's not real, Here, the causal structure manifests a real physical property because of, the principle of relativity and relationalism. So this is the main difference between functionalism and what I do here. That's why we need physics to begin with. in order to have manifestation of physical properties. And only then we can show how we take causal relations of affective valence, and it will manifest in the right frame of reference inside a simulation as a real physical property that has something that is like.
Let me ask you something funny. How many consciousnesses are there inside you right now?
Wow. Yeah, this is a very good question. Yeah. Okay, so you know what? Before that, let's summarize then. What are the conditions to have consciousness? What we saw is that in order to have consciousness, first of all, we need a cognitive system that can learn and create all those representations. And then it needs to create a simulation. Okay, so we will have this intrinsic frame of reference. And then we need affective valence as one of the variables in the simulation. And this affective valence will be manifested then as something that is like, as phenomenal property. Okay, so we need a cognitive system that creates simulation, and one of the variables of the simulation is affective valence. Then any frame, and another one. Oh, of course, I forgot something very, very important, actually. Affective valence tells the system what to do, right? Is it good or bad? And then the system can, let's say, decide what to do. So for that, we are inside the simulation. So in order for that to work, we need to simulate the system itself, not only affective valence. So we simulate all, the outside world. We simulate the system itself.
Okay.
And then we simulate also affective valence, like, is it good or bad for me? So inside the simulation, let's say, inside the simulation, there is an apple. Affective valence gives it a number, very good. And then the cognitive system that is simulated inside the simulation, right, can use it in order to create appropriate outputs. Okay?
Okay.
There is, as we said before, there is like a causal power here. Affective valence actually do something and changes the cognitive system. So the cognitive system must be also, represented, let's say, as a variable in the simulation. Okay, so we have then 4 conditions to have a cognitive system that creates simulation, and inside the simulation we have a variable of cognitive valence, and we have a variable of the cognitive system itself. Okay, then it must be because of relationalism in the frame of reference inside the simulation of the cognitive system. It will have a phenomenal property. What is it like to eat the apple, right? Bad or good?
Okay. Let me see if I got it. Okay, so number 1, you need a simulation, but not just any simulation counts. So you need some other conditions. The simulation needs to assign some loss landscape, some good and bad. Okay.
Mm-hmm.
Okay, so that's number 2. Then you need to simulate yourself somehow. Simulate the system. The system needs to simulate its own simulation, or the universe.
No, so it's not infinite recurrent here or something like that. The system. So why do we need to simulate? Why does the system need to simulate itself? Because the simulation tries to catch everything that is out there, right? The cognitive system is part of the world. So if we try to understand the causal relations of the world, we need also to take into account ourselves, to take into account the cognitive system itself. Okay, but we don't need. Okay, but it's not. We don't need it to be very sophisticated. It can be only something that that gets how to say, get information from affective valence, the affective valence, that will say it's good or bad for you, right? And then it needs to decide what to do with that. So this is what is needed to be simulated, as a cognitive system inside, the simulation. The fact that, it's a system that gets the information from affective valence and decides what to do. Okay, that's it. We don't need much more than that.
Okay. So condition 3, which is that it needs to simulate itself, is necessary in order for it to determine actions to take, and the ability to take actions is condition number 4.
So the ability to take actions, you can say, yeah, it's also a condition. Just the thing is that we need causal relations here, right? Causality, this is what will manifest in the end of the day as physical properties, right? So the simulation learns the structure of causality from the outside world. And then we have this affective valence. Is it good or bad for you? And it has causal relations with the system, right? It says, it like dictate the system. Oh, it's good for you, it's bad for you, and then the system can decide what to do. And these decisions are also another causal relations with other properties, other inputs that are outside in the world. Like you take the apple, for example. So you need to take those into account as well, right? You need to take as much causal relations as you can in order to create, a stable simulation, a simulation that always can run, that will never break. This is very important. A simulation needs to never break, to always, that can always run, and then, because of that, you need to take into account, you need, to simulate the system, the cognitive system itself, affective valence itself, how they cause and affect each other, how the cognitive system has causal power on other inputs, right? So all those needs to be part of the simulation.
Now, Nir has how many consciousnesses inside him?
Right. So in order to answer that, we need to check how many simulations my cognitive system can create. If it can create only one simulation with affective valence and with the simulation of itself, then I will have one conscious frame of reference, the frame of this simulated cognitive system. If for some reason we have couple of those simulations, then I will have couple of consciousnesses. Those experiments with the split brains. It's very interesting, right? In the 50s and 60s, I think Gazinga was the first one that did it. People that had very severe epilepsy, and they cut the corpus callosum, the part that connect the two hemispheres, and then they saw, that most of the activities of those person, most of the activity was okay, but they had some weird consequences. And it seems like each hemisphere has its own consciousness even. It's hard to know if this is the case, of course, but this is how it seems like. One, you can ask the left hemisphere, what does it see? And it will tell you, because the speech areas are in the left hemisphere. And you can ask the right hemisphere that cannot talk, what do you see, by, painting, drawing something. And it, and you can show them different things and they will say different things, right?
Yeah.
And by the way, some people have speech areas in both hemispheres. And then some of those that had this brain split, they can actually ask one ear, what do you would like to do when you will be when you grow up? And then the same question in the other ear. And each time they will have different answer. So it seems like that maybe the two hemispheres have their own consciousnesses. So each of us has at least two. If it's true, then it means that we need to find, if my theory is correct, then there is two simulations that simulate the actual, simulate affective valence and the cognitive system, one in left hemisphere and one in the right hemisphere. And if even more, who knows? What I think that it might be that we have a couple of simulations, but all of them are integrated into one big simulation. Because when you think about it, as I said before, the simulation needs to be stable. It cannot be that, it will break for some reason, or, it doesn't know what to do with some kind of inputs. So it needs to be very sophisticated. And we know that in our brain, we have different areas that control different aspects. One area for vision, one area for auditory, and the area for colors, for movement. So then all of them needs to coordinate together in order to create this simulation. So it seems like there will be only one simulation that takes all those areas together to integrate them together, so we can have one good simulation that doesn't break. Maybe two, maybe each hemisphere can do it by itself. This is something that we need to check. So this is something that actually we can do a prediction here and check if the theory is correct or not, using such, those conditions for consciousness. Now we can also answer other questions, deep questions about which animal has consciousness, for example. Or does babies or newborn babies or fetus, do they have consciousness? Of course, about GPT or AI, right? Do they have consciousness? Can they have consciousness?
And in the case of LLMs, your answer is?
So LLMs, the quick answer is no, they don't have consciousness. The reason is that, LLMs learn the causal relations between words. You can say that, each word has some causal power of other words, right? And the context and the sentences, and there are the grammatic rules. So GPT and LLMs they need to learn these causal relations. And theoretically, they might create a simulation of those causal relations. So we are in a good direction, right? I mean, it met at least two conditions to have consciousness. You have the cognitive system, and it created the simulation. But then what about the two others? They don't really have any simulation of themselves inside, and they don't have any affective valence, just because this is not how they function, this is not how they work. They don't use affective valence, and they don't have any representation of themselves inside the simulation. We don't even know if they have a simulation, let's say. I remember reading a paper 2 years ago, I think, that showed that if you take LLMs, they sound very intelligent. They sound that they have understanding, But then if you change enough the problem, they will stuck. So they don't really understand all the relations, all the causal relations, all the structure, all the causal structure underlying the question and the problem. If they would understand it, then they will not stuck. They will know what to do in order, to cope with the changes that you did in the question. But for now, at least, they stuck. So it means that maybe they don't even have a simulation, But even if they do, they don't have any simulation of themselves and any effective valence. So that's why they cannot create this what is it likeness physical property. So they don't have, but of course that in principle, we can create AIs with consciousness. We know what to do, right? We know now all those 4 conditions. So if they will meet them, they will have consciousness as well. They will have something that is like very rudimentary, maybe in the beginning, but then they will continue to learn and they will create much more elaborate consciousness, just like us. So in principle, we can do it. It's a bit like what we see in sci-fi movies, right? In principle, now we can take your brain or the audience brain, understand the dynamics over there, mimic the same simulation that is created in their brain, but do it now in a computer. So if it's exactly the same simulation, then again, inside the simulation, we'll have the exact same variables that simulate affective valence and that simulate the system itself. So then, the frame of reference of the simulated system will have consciousness, right? It will have the same exact physical properties that will be manifest there. One of them is this: what is it like? Is it good or bad for me? With all all this simulation, with all the all those causal relations. And in the end of the day, we will get the same simulation with the same properties, with the same phenomenal properties as well. And then we actually copied ourselves and our consciousness into a computer.
Nir, I have so many more questions for you. I have to get going soon. So I have to choose my questions carefully. There will very likely be a part 2. So if you're watching this, then please leave a comment for questions for Nir for the second time, because this podcast was more an introduction to the ideas of Nir, and then we can get into even more questions about his particular theory in part 2. But anyhow, what do you make of Chalmers' zombie argument?
Yeah. So the zombie argument, I wrote about it in my first paper. The zombie argument, so maybe let's say quick what is the zombie argument. So maybe first of all, let's state quick what is the argument. Because we saw that phenomenal properties are different, you cannot reduce them to any physical dynamics, then it seems that you can think of a creature, this philosophical zombie, that is identical to me, for example, in its physical shape and all the physics of the brain and all the neuroscience of the brain. Everything is identical to me, identical body as well, but with no consciousness. Again, because it seems that consciousness is just independent from the physical, right? If you don't take into account the principle of relativity. So Chalmers argued that we can think of those zombies, zombies that are exactly like us, but have no consciousness. Now, the thing is that when we take the principle of relativity seriously enough, then zombies cannot exist. Because if you remember do you remember the equivalence principle? It seems like we talked about it so long ago. Time is relative. We can do an equivalence principle here, equivalence principle of consciousness, by saying that the argument of zombies is they are completely the same. They identical physically to us. But then, according to the principle of relativity, if all the measurements that we can do show us that they are identical, then they are really identical. There is an equivalence here. There cannot be an absolute property that will distinguish between them, according to the principle of relativity. And we did all the measurements that we can. Those measurements include everything that you can think of. Measurements of course, what is the behavior of the zombie. Measurement of what is going on inside their brain, the dynamics of their neurons. Measurements of what do they say, what do they report. And we see that it's all the same. This is part of the argument, right? Of the, zombie argument. So there is no way how to distinguish between us and the zombies. And because of that, if we, respect the principle of relativity, it means that they must have consciousness as well, just like us. Because if they will not have consciousness, then the principle of relativity will break, right? Although we measure that they are exactly the same like us, then there is no difference. There actually is a difference. They don't have consciousness. So the principle of relativity would break. So we need to choose. I choose the principle of relativity, right? That this is a principle that is the basic principle in reality. And that's why zombies cannot exist, because we cannot distinguish between us and the zombies. They must have consciousness as well.
Okay, two thoughts occur to the listener. One is, you keep saying that consciousness is not an absolute property, it's a relative property. They may be thinking, Nir, are you saying that me, the listener, that I am not conscious, or that my consciousness as the listener depends on someone else's consciousness, and vice versa?
So it depends. Consciousness, yeah, because it's not absolute, it depends. It depends on the frame of reference, right? And what we saw is that the frame of reference that manifests consciousness is the simulated cognitive system inside the simulation, right? So the answer for the audience is that inside your simulation, inside, quote, quote, your brain creates a simulation, and in this simulation, there is a frame of reference of the simulated cognitive frame, and then this is where consciousness is manifested. Because as we said before, the simulation, all the causal power of the simulation is the causal power that comes from the variables that create the simulation. And those variables are the external world, but also the simulated cognitive system and affective valence, right? And because of that, now we have physical properties of the outside world and a property of, is it good or bad for me? This is the what is it likeness property. And the one that measured this property is exactly the frame of reference of the simulated self, of the simulated cognitive system, inside the simulation. This is the frame that measures the affective valence. Let me remind you. Let's say that I see an apple, I see an apple. What it means? What it means is that there is a real apple outside. Light from the apple meets my eyes. It starts all those causal, dynamical, processes. In the end, it will influence the simulation. So now all those variables of the simulation will have all this causal structure of the apple. Part of this causal structure is also affective valence, this variable that state, is it good or bad for me, right? So the apple now has this, oh, it's good for me, right? But affective valence, it interacts with, with the cognitive system. The cognitive system is the one, that get it this information. Is it good for me or bad for me? That's why we need to have the cognitive system as part of the simulation. Okay? And in the simulation, this cognitive system get the information from the affective valence. Is it good or bad for me? Get the information about, the apple. So that's why the cognitive system inside the simulation manifests all the relations. So manifest, because of all the relations, it manifests all the physical properties of the apple, and also all this, is it good or bad for me? This, what is it likeness for me to have the apple? Okay? So the answer is that the audience consciousness, your consciousness, comes from your own simulation that your brain created. And that's why from any other frame of reference that is outside of the simulation, we cannot measure it. That's why we see, remember that we spoke about the coin, head and tail. This is exactly why we have the head and tail here. Only in the frame of reference of the cognitive frame, of the cognitive system inside the simulation, only there will be a manifestation of what is it likeness, of the affective valence. Any other frame of reference will not have this, will measure different relations, and will not have these relations of affective valence, and will not measure this, what is it likeness, okay?
Let me ask you this. Relativity requires two frames to be meaningful.
Yes.
So velocity is relative to something. If consciousness, or one's own consciousness, is ever observed from one's own frame, from one frame, the system's own frame, then it doesn't seem, in that case, to be relative to anything. It just seems to be an absolute first-person property. But we just use the word relative to describe something absolute, where there's no second relatum.
So we need to distinguish here between, there is a bit of a problem here of names, labeling stuff. Because we started from a cognitive frame of reference, which is our brain. And then we went into the simulation, right? And we discussed that inside the simulation, you have lots of frames of reference, that for them, all the causal power are the variables of the simulation, right? So for them, the variables are the entities. One of those frames of reference is the frame of reference that represents our brain, represent our cognitive system. Okay, to represent it inside the simulation, right? This is the frame of reference that measures consciousness. It measures all the variables, right? And all those variables now are entities, like apples and gravitation. But now, one of the variables is also, what is it like? Like, is it good or bad for me to have gravitation, to see an apple, and so on, right? So this is the frame of reference. This simulation of a cognitive system, this is the frame of reference that measures consciousness. If it will not be inside the simulation, there will be no frame of reference that will measure consciousness. You see, so that's why it's not absolute property. You need a frame of reference inside the simulation to measure consciousness. Okay, without it, nothing can measure this affective valence.
You need a frame of reference inside the simulation to measure consciousness or to experience consciousness or to be. Like you're measuring consciousness inside the simulation of yourself?
So when you measure something, then it can be manifested, right? When you measure all the relations, like someone in the spaceship measured her surrounding, and gravity was manifested, right? So now we are inside the simulation. We have a frame of reference inside the simulation, right? Of our brain, let's call it, so it will be a bit easier, okay? Now, it's inside the simulation, but again, this frame of reference has causal power with all other variables of the simulation, right? Those are the measurements, okay? And because of that, physical properties will be manifest, like an apple, and so on. And one of them is the affective valence. One of them is that, is it good or bad for me? What is it likeness?
Let me jump in here. Here's where I'm confused. Why is there a what it's likeness associated with the good and the bad? It seems to me that that's exactly what the hard problem is. So we can state that measuring this good and badness is a what it's like property, but that's precisely what the hard problem is asking. Why does this good and badness measuring, or why does a loss landscape, or what have you, why should there be any feature of what it's like associated with it, or entailed by it, or implied by it, or whatever?
Okay. In order to answer that, let's think of another property. Let's think of location in space. Okay? So let's say that now we are inside the simulation. There are lots of variables, lots of entities, and all those causal structures will manifest a location in space for each entity, for a tree, for the apple, for myself, right, for my body, and so on. Now, this location, it was a causal relation, but now it has manifested as a property, as location in space. Now, each entity has a location in space because of that. Like the apple has a property of a location in space. Where is it in space, right? Because of the causal structures to other variables. Okay, so now we can attach to each entity a property of a location. Where is it? Same thing is happening with affective valence. So now we can attach so now we have our brain inside the simulation, right? And this brain, as part of the interactions with all other entities like the apple, has now a property about the apple. Is the apple good or bad for me? Okay, so now it's just like a property of location. Now the apple has also another property of is it good or bad for me. But notice that this property wasn't there to begin with. It's not like what we would call a proper physical property. It's not a location, a velocity, it's not a frequency. It's something new that wasn't there before, but now it's part of physics. And so what is this something new? Well, just like location, it's just like you can think of it as a number that tells you where the apple is in space. This affective valence is just like a number that tells you that this apple is very good for me. Okay? But now it's a physical property, actually. So we managed to add to physics a property about is something good or bad for me. It's not something that that exists outside in the world. It's something that exists only in the simulation. And this is exactly what we would expect from qualia or from phenomenal properties. Because phenomenal property seems like it's very different from every canonical physical property, like, location and so on. And also this, is it good or bad for me? It wasn't part of the outside world. It is something that we added to the system. And it's related to to the cognitive system itself. It's like a subjective point of view. Is the apple good for me or bad for me? Now it's a subjective point of view, but it's part of physics, this subjectivity. It's now a property that the simulated brain measures about the apple, right? It's part of the apple now is that it's good for me. It's like it has a subjective value for me, okay? The subjective value is it good or bad? So this is exactly what we would expect from phenomenal property. Now we have something that is like, in the sense that it's a subjective relation, between the simulated brain and the simulated apple, right? This subjective relation now has manifested as an actual physical property. Okay, so subjectivity now became part of physics. So that's why we can say, that we have something that is like now as part of physics. We have phenomenal property as part of physics. Okay, just because it adds subjectivity. We didn't have subjectivity to begin with, right? Without the simulation, without this affective valence, all there are, in the simulation, without let's say we have a simulation with no affective valence, but we still have a simulation of the outside world. All those variables of the simulation will manifest stars and everything, just like in our previous example of the simulation. But there is no subjectivity. But now affective valence added subjectivity. So now all these apples and trees and what's not, all of a sudden has a meaning for me, It's like good or bad for me. Right? For me, I mean for this brain, the simulated brain, okay? Inside. So that's why now all of a sudden we added a new physical property that wasn't there to begin with. And this is exactly about what is the cognitive system, how it relates right? How it relates to all other inputs, right? This is the subjectivity, how it relates to them. And then again, it starts very rudimentary, like good or bad, but then it can become much more sophisticated, when you take more relations into account.
Nir, I appreciate you coming on the show. I appreciate you spending over 3 hours with me when I think we're both not well, we're both sick, and so I very much appreciate your time. And I would like to speak to you at some other point about your upcoming papers and any theories of physics in particular. Today's episode was about consciousness/observers. I want to know, the audience wants to know, where can they find out more about you? That's the ordinary audience, let's say the bulk of the people. And number two, there are many researchers who watch this channel in cognitive science, philosophy, etc., blah, blah, blah. They may want to know, how can I collaborate with you, learn more and collaborate? And number three, there may be people who have some funds who want to test your theory. How can they fund such research? So where do they find out more about you? How do they contact you to collaborate with you? And then how do they contact you to potentially fund some of these experiments?
Yeah, okay, so let's start from the first question, I guess. You can find me in Facebook. Usually I love to explain science, so I do it in Facebook and in Instagram, and I even have YouTube channels where I upload some videos. I'm from Israel, so for now most of my videos are in Hebrew, but I will gradually I will also do some videos in English. And of course you can read my first paper, and hopefully in a couple of months my second paper. So this was the first question. About the two other questions, it's a very good idea, actually. So I come from physics, and I do something here that is very multidisciplinary, right? It's like philosophy, physics, and neuroscience all together. So it means that collaborations will be very good, very much good idea. So if there are philosophers that would like to collaborate with him, for example, Zachariah Nime was the philosopher that I wrote with him my first paper. And now I would like to write a couple of more papers, for example, how to solve the Chinese room argument. This is something that I think we can solve with the relativistic approach as well. It would be nice to do it with a philosopher that actually knows much deeper than I do all the fine details of, the Chinese room argument, right? So if there are philosophers that would like to collaborate with me, it can be great. And if there are neuroscientists that have the experience of analyzing, fMRI, EEG, and so on, it can be great, because again, I'm not a neuroscientist, so I need collaboration with that. These days, I'm in the consciousness and cognition lab in Cambridge University, in order to try and understand, try to build a new testable predictions, and then to build the actual experiments in order to test the theory. So for that, of course, also I need, it will be helpful, to have collaborations. And as you said, the third point is very important as well. I'm the new kid in the block. I have a new theory of consciousness, and it's hard to get funds for new theories, especially in consciousness, especially something that is multidisciplinary. So like physicists will not understand why consciousness is so mysterious. And neuroscientists don't really like the physical point of view that I bring. So it's like in the middle, you know? So it's really hard to get collaborations and funds. Usually there are not lots of funds. It's interesting that in academy you have two opposite forces that battle each other. One force is the ideal. We know that reality is bigger than what we can imagine, right? So we know that we need to think outside the box and be creative, right? But then the other force is that no one has money. No one has funds. And the outcome of that is that even if a researcher do have money, they need to invest it only in what they do, only in the experiment that will give them the results that they need in order to continue, with their own research. They don't have the funds to do this exploration, to do this out of the box thinking and so on. So that's why it's very hard to get funds. So if someone have means and would like to help us to fund those, the experiments and all this postdoc that I do, then please, by all means, get in touch with me, because it can lead for an amazing result, right? Amazing results. So you can find my email, of course, in my papers, and just send me emails, and we'll take it from there.
Thank you, Nir.
Thank you very much, Curt. It was amazing to be in your podcast. I love to hear your episodes, by the way. I'm one of your fans.
Fantastic. Hi there, Curt here. If you'd like more content from Theories of Everything and the very best listening experience, then be sure to check out my Substack at Jaimungal.org. Some of the top perks are that every week you get brand new episodes ahead of time. You also get bonus written content exclusively for our members. That's CurtJaimungal.org. You can also just search my name and the word Substack on Google. Since I started that Substack, it somehow already became number 2 in the science category. Now, Substack, for those who are unfamiliar, is like a newsletter, one that's beautifully formatted. There's zero spam. This is the best place to follow the content of this channel that isn't anywhere else. It's not on YouTube. It's not on Patreon. It's exclusive to the Substack. It's free. There are ways for you to support me on Substack if you want, and you'll get special bonuses if you do. Several people ask me, like, hey, Curt, you've spoken to so many people in the fields of theoretical physics, of philosophy, of consciousness. What are your thoughts, man? Well, while I remain impartial in interviews, this Substack is a way to peer into my present deliberations on these topics. And it's the perfect way to support me directly. CurtJaimungal.org, or search Curt Jaimungal Substack on Google. Oh, and I've received several messages, emails, and comments from professors and researchers saying that they recommend Theories of Everything to their students. That's fantastic. If you're a professor or a lecturer or what have you, and there's a particular standout episode that students can benefit from, or your friends, please do share. And of course, a huge thank you to our advertising sponsor, The Economist. Visit economist.com/toe, TOE, to get a massive discount on their annual subscription. I subscribe to The Economist, and you'll love it as well. Toe is actually the only podcast that they currently partner with, so it's a huge honor for me, and for you, you're getting an exclusive discount. That's economist.com/toe, TOE. And finally, You should know this podcast is on iTunes, it's on Spotify, it's on all the audio platforms. All you have to do is type in Theories of Everything and you'll find it. I know my last name is complicated, so maybe you don't want to type in Jaimungal, but you can type in Theories of Everything and you'll find it. Personally, I gain from rewatching lectures and podcasts. I also read in the comment that TOE listeners also gain from replaying. So how about instead you re-listen on one of those platforms like iTunes, Spotify, Google Podcasts, whatever podcast catcher you use. I'm there with you. Thank you for listening.